Hello and welcome once again to this webinar in partnership with UNIMORE. So this event is of course dedicated to the engineering and physics department. So you will get to know more about the masters available in this field, and of course any questions that you might have regarding the academic offer, the exam sessions, the admissions procedure, and anything related to the student life, feel free to write in the Q&A box, and we'll be happy to take your questions at the end of the presentation. So, of course, we have three professors from UNIMORE, and I'm going to introduce each one of them. We have Professor Luca Selmi. He's the full professor of electronics at UNIMORE. Professor, welcome. And thank you for your time. Thank you for being here. Then we have Professor Guido Goldoni. He's the full professor in physics of matter in the Department of Physics, of course. Professor, welcome.
Thank you very much.
Thank you for your time. And last but not least, we have Professor Manuel Iori. He's the full professor of operations research. Professor, welcome and thank you for your time.
Thank you very much. Thank you.
Thank you so much. So once again, welcome to all of you. Just as a recap, this event is dedicated to the masters in engineering and physics. So if you have any questions about the academic offer, about the exam sessions, about the final dissertation, if you are particularly eager to know all the details, feel free to write your questions in the Q&A box and we will answer them at the end of the presentation. Now, without further ado, I would like to leave the floor to Professor Selmi. And Professor, the floor is yours.
Okay, thank you, Lavinia. Thank you, everyone. And can you hear me well?
Yes, I confirm.
So let me share the screen, and I will start with the presentation. Okay, do you see my screen now?
Yes.
Okay, very good. So, good evening again. I'm here to present and talk about this master degree in electronics engineering, which is activated by and managed by the Department of Engineering Enzo Ferrari. It holds a name, a very famous name of the car maker Enzo Ferrari. The department is located a couple of kilometers from the town center of Modena, Reggio, Emilia. And it's actually a nice and wide campus, as you can see here. The department has about 120 professors and at least 2x times early stage researchers and PhD students. And you can see some of the major figures here listed. I'd like to emphasize that the lab activities and are actually enriched by strong links with the centralized large instrument laboratory and the Center for Scientific Computation of the university. I don't think I have to explain you what electronics engineering is, although I have a slide here because if you are listening to this presentation, you probably already know. So let me immediately address what maybe is the main topic of this presentation. So why should you enroll at electronic engineering at UNIMORE, and what has UNIMORE to offer you? Well, one good reason actually comes from a recent result which I report from the press, which reflects the standing of UNIMORE in electronic engineering as far as European projects on electronics and on electronic components and systems, where UNIMORE ranked first at national level for its ability to gather new projects at the cornerstone of new industrial strategy and in the field of electronics. So this is witnesses that the standing of UNIMORE in this field is quite large. And indeed, here you will find in the slides that we'll send you later also the contacts to many European projects that involve professors of electronics here at this department. which cover all aspects of modern electronics, which go from research on very new materials and devices, which is, for instance, gallium nitride, to applications for sensors, advanced sensors for the automotive industry, or sensors for wearable and portable electronics for health, and so on and so forth. So the study program is actually organized in a very simple way. Meaning that aside from common courses that strengthen your foundational, your knowledge of the foundations of electronics and the methodologies around electronics, we have basically two curricula which address different complementary roles that an electronic engineers and profiles that an electronic engineer can have in his professional activity within industry. On the one hand, we have a world which is roughly speaking identified as that of industrial automation, okay, which includes, of course, robotics, automotive. This Modena is in the middle of the Motor Valley, where all the largest and most important companies building first-class cars such as Ferrari, Maserati, and motor bicycles, Ducati, and so on, will actually have their premises and their headquarters. And also, of course, the themes of energy, manufacturing, and all the control electronics that goes into it. On the other hand, we know that new devices with new materials are at the basis of the ability to design and to manufacture smart and connected systems, which can be wearable, which can be sensors, which are highly interconnected, which should exchange, generate and exchange the so-called big data. So our study program is organized around these two curricula, and the main basic structure of the courses is shown here. And as you will notice, the number of credit points for each semester. Remember that overall you will have to achieve 120 credit points in order to get the master's degree. Are basically distributed as you see here, and the blue and the red courses are for the two curricula. Now, wherever you see sums which are smaller than 30 credit points per semester, that means that you have free credit points basically to follow additional activities of your choice in the vast and large offer that the course of study gives you. So to tailor your education in this field, we also with respect to your main interests. Among the elective courses that are available, these are just a few that are listed. We don't only have specialized courses on specific topics such as automotive electronics or automotive connectivity, so electronics to connect cars and vehicles in general for the mobility, the smart mobility, the smart cities, and so on, but also the possibility to include friendships and design activities. This is very important because the region that hosts UNIMORE is actually one of the most active, alive, and with the industrial, a very rich industrial environment, where you will be able to take stages also within these companies. Also, we try to build up, actually we work hard to keep the course of study tightly linked to the international arena, and to this purpose non-Italian university professors from different universities are called to teach specialized courses for very specific topics, and this is just a list of some. This list is continuously updated every year with new professors that are posted for this purpose. And again, you see that the topics span over both curricula. Another richness that we can list and another point of strength that we can mention for the EE course of engineering in electronics here at UNIMORE is the large number of research labs that support our research activities and that are accessible to the students in many ways. Both within the courses, many courses of the master degree have projects inside, which you will carry out inside of the research labs, and as environment to build up your thesis work, master thesis work. And you have the link here with the list of all of them. These are just a few on the photonics field, communications and signals, optoelectronics, micronanoelectronics, and so on and so forth. This is just a snapshot of one of them. Each of these labs has actually quite rich equipments and instrumentation available. For instance, this is a device characterization lab, and there are as many as 3 different probe stations. Those of you who have heard a bit about these machines know that these are quite expensive and important pieces of equipment to carry out research, for instance, in micro and nano electronics. This is another snapshot just to illustrate the fact that besides the experimental activity in the lab, you will also have access to a lot of software tools for engineering analysis and to strengthen your ability to analyze engineering problems and solve engineering problems with the use of a technology computer-aided design, which is a mandatory ingredient of the education path of any modern engineer, I would say. Let me say a few things also about a few more things about the traineeship programs. This map, which is actually accessible at this link, lists some of the main industrial areas, actually companies, sorry, not areas, with whom the course of study has direct and specific connections that have been actually exploited by our students in the past. Of course, there are many more companies that you will be, where you will be able to spend your stage with dedicated programs. And you can browsing these, you will be able to see that these companies cover all possible aspects of electronic engineering and represent the richness of the course of study. The traineeship can also be replaced or flanked by an internal design activity within a research lab. So sort of an internal traineeship, which is actually an actual research experience of approximately 4 months for 720 hours approximately, with many projects related to the European projects and research projects and the collaborations. The nice and interesting point is that this design activity can be combined with the credit points that are delivered for the master thesis, so that you will be able to develop a larger, more robust and even more interesting master thesis by combining these two experiences. One other strong point of our course of study is the connections that has with many universities worldwide and in Europe via the Erasmus Plus project and more overseas programs. Okay, and again here you have the link to a map which lists at least the main locations where you will be able to spend a few months and take some credit points also abroad, so that your education will be really international and at least European, not to say. One option that you also have is to take a double degree path. We have established a double degree path with the Università Tecnologica Federale do Paraná. This may be a very interesting opportunity also for students coming from Southern American countries. This option allows you to take 1 year of education in Italy, in Modena, and 1 year in Brazil, and eventually get a degree which is recognized both in Brazil and South America and in Europe, because it's an Italian title and it's part of the European education, higher education system. This is a special path that is already set up, and we already have students that actually took these double degrees in both directions. So to wrap up this presentation and leave room for questions, I basically think I gave you some clear facts demonstrating that electronic engineering at UNIMORE is a really international course. It is entirely taught in English. It is a multicultural environment and with cutting-edge contents, recognized, externally recognized cutting-edge contents. The satisfaction rate of our students is extremely high. The employability is close to 100%, and the salary levels for electronic engineers are actually higher than the average of for students from the Modena area, higher than the average for other parts of Italy. In the Emilia-Romagna region is the third highest for GDP per capita in Italy, and this gives tremendous opportunities of professional growth. We have many research groups which demonstrated a successful track record in the most important European programs for electronics. I mentioned the double degree at the master level, but I spend the last 2 words to say that our master degree is also an excellent stepping stone toward the PhD degree in ICT that we also have, fully international, tightly linked to industry as well. And you can find more information on that at this link. And also for the PhD program, you have a double degree option with the Technical University of Vienna in Austria. So having said this, I leave with the last slides the institutional contacts for the course of study, besides the contacts that will be given you by the Central International Welcome offices. And I thank you for your attention and leave the ground for questions. Thank you again.
Professor Goldoni, I think you are next.
Okay. Okay, so thank you very much, Lavinia, for the invitation, and I hope you can hear me well.
Yes, I can hear you.
Okay, great. So here you can find some information, which I will also flash in the end, where you can find more information about our degree. So our department is a strongly research-driven department. That means that our master degree, and of course also the graduate school which follows, are shaped by the scientific research activities of our teachers. And also the teaching is shaped by interaction with other actors locally or internationally. For example, we have interactions with other departments in chemistry, engineering, applied sciences, medicines, for example. We have in our building the headquarters of a National Research Council Nanoscience Institute. We are interfaced with technopoles in our region, which are experts in mechanics and energetic applications. And as my colleague has already told you, we are in an environment which is strongly advanced from the industrial point of view, and our students are normally employed if they decide to stay in this region, in the automotive sector, for example, in the biomedical district, which is nearby, in the ceramic industry and food and packaging, which are companies which have their research centers in Modena or in the surroundings. Now, our degree is organized in 3 curriculum. I will tell you about the curriculum later, but in common, the curriculum have that you have to take about 11 exams to take your degree, which mixing both theoretical and experimental activities, because a physicist should know somehow both from both sides. The curriculum have a large flexibility, so we have very few compulsory courses, and you can choose most of your courses, and you can even choose some course from other degrees, often from engineering, for example, or mathematics, but also economics, for example. We have activities for the professional preparation, whether you want to go to the job market or learn about the research ecosystem, if you prefer to stay in research, for example, if you go on with a PhD, and also practice with a group of students the design thinking paradigm in collaboration with companies. To take the degree, the teaching program ends with a thesis research project, which normally lasts from 6 to 9 months, which is always an advanced original research project at the cutting edge of research. We have some special programs I will tell you about, and our students are entitled for free Italian classes for beginners. So you will leave it, you will end the degree, and you can also speak good Italian. Now, the 3 curricula are theoretical and computational physics, experimental and nanophysics and quantum technologies, and biophysics and applied physics. And I will go through the 3 right now. So theoretical and computational physics has 2 group of courses. You will learn about fundamental interactions, the standard model of particles, string theory, general relativity, quantum computation, all the foundations of modern physics. But on the other hand, you can take courses which will teach you how to simulate matter, both of inorganic or organic type, or even hybrid organic inorganic materials, particularly nanomaterials, so simulations of matter at the nanoscale, biological matter, interactions between systems at the surfaces, how simulation of nano devices in nanoelectronics, spintronics, and so on. In common, these activities have a very strong computational content. So you have to learn, you will have the opportunity to learn how to use the most powerful computers in Europe. So here you see the list of courses. The point is that you have only 4 compulsory courses about quantum field theory and advanced, basically quantum theory of matter. And then you have a group of courses within which you can choose those who are more interesting to you, both fundamental physics or computational physics. For example, you can learn here how to simulate biomolecules or other materials, or how to program quantum information, quantum computers, or learn about high performance computing techniques and machine and deep learning techniques and so on and so forth. The second curriculum is strongly an experimental curriculum. That's about nanophysics. So you learn how to fabricate nanostructures, how to apply electronic and scanning microscopies, how to look at matter by electronic and optical means, how interfaces and surfaces of materials behave, which are the tribological properties, for example. And another set of courses is about quantum technologies. Spintronics is one building block of this, but there are other quantum technology you will learn about. And in general, quantum materials, so materials whose properties are intrinsically linked to their quantum nature. Again, you have only 4 compulsory courses in this curriculum, mostly in a lab. But you have also to take some theoretical physics course, and you can choose other courses which will allow you to specialize in one part of the discipline or another. For example, advanced spectroscopies, or how to use synchrotron radiation to investigate matter, or how to electronic and holographic microscopies, and so on. The third curriculum is about biophysics and, in general, applied physics. There are 2 main activities in this curriculum. So one is about the biophysics, so how to study biological matter by the methods of physics and chemistry. For example, how to study protein foldings, the way proteins fold up to perform the unique physiological functions, but also medical physics, by which you can employ your knowledge, your expertise as a physicist very near to the clinical level by, for example, managing imaging apparatus, or use machine learning techniques to analyze images and so on. Another set of courses will allow you to develop advanced methods, both numerical and hardware methods, for example, for investigating matter, or applying those apparatus in also commercial products. There's also the possibility to specialize in the didactics of physics, because some of our students are highly motivated to teaching physics in the high school, for example. So, as I told you, the curricula are very flexible, so you can choose most of your the courses according to your interests. So what you can do is to design a very personalized study plan and become an expert, for example, in theoretical and computational physics of matter, or in biophysics and study biological system, or even work in an hospital as a medical physicist. Or you can become an expert in the foundations of physics, so fundamental interactions like standard model and so on. Or you can specialize in quantum information processing, which is the next revolution of quantum, the next technological revolution, most people believe. You can become an expert in nanoscience and nanotechnologies, or in the numerical methods and algorithms which are behind applied physics. As I told you, also become an expert in the didactical method for high school teaching. Now, I mentioned special programs. One of maybe the most important of them is a double degree program. You can you can enter a double degree program with the Radboud Universiteit in Nijmegen in the Netherlands, which and take both the physics degree in Modena and the physics and astronomy degree in Nijmegen. This university is a very peculiar and very important university for the research in physics in Europe. They run one of the largest high magnetic field facilities. They are involved in the gravitational wave detection and all the most important projects now in modern physics. So this is a great opportunity, spending 1 year in Modena and 1 year in Nijmegen to take the best of the two worlds. We have the program of excellence. So if you are if the courses are not enough to you, you can have a personalized program of additional activities. And the advantage is that if you if you go on for a PhD in Modena, those activities which are in your personalized program will be recognized by the PhD program. So in a way, you shorten your PhD program afterward. If you want to live for an Erasmus experience, then you can go to one of these 5 sites: Oviedo, Spain, France, Netherlands, and Vilnius. Each of these sites have a peculiarity, so you may be motivated in one way on a scientific basis. Normally, you may be motivated to go to Grenoble, where there is a very famous synchrotron facility, for example, or in Nijmegen because you are going to do high magnetic field physics and so on and so forth. And our teachers are here to advise you which site is better for you. Okay. And if after the degree you don't want to continue for a PhD, but you want to hit the job market, the job market directly, then we have professionalizing courses, and we have a program by which you can meet with professional physicists, which are employed at our top level in the industrial environment. So you can ask for advices, and you can be guided in your entry in the job market. So to sum up, why studying physics in Modena might be particularly interesting to you, I would say that the first point is the quality. So that we have, apart from the high quality of the teachers, of course, but also there is a small number of students. So we have about 20 students per year. That means that in the classroom, you are from 5 to 10, 12 students maximum, typically. So there is very high teachers to student ratio. You can be followed by very closely in your studies. Flexibility of our curriculum is always very much appreciated by our students. So the curricula are also interoperated. So you can enter one curriculum, you have to choose one curriculum, but then you can take some of the courses from another curriculum. So if you want to mix the curricula, that's also possible to some extent. It is an international environment, not only because the degree is taught in English, of course, but we have a double degree program. As I told you, you can go for an Erasmus in several very prestigious places, and we have a strong program of visiting professors. So professors which are teachers, which are professors abroad in other university in Europe or US normally, which come for a semester and teach a course in our degree. And last but not least, Modena is a small, lively city, and is very well connected. So for international students, it might be interesting to know that our university campus, as well as the engineering campus, has a direct connection to the Bologna airport, which is an international airport and an Ryanair hub. So if you decide to enroll for an online interview, this is the selection step. So we interview you over Skype, and this is a non-binding step. What we will do in this interview is to value your background in classical physics and quantum physics. So we want to know that you have a normal background, which is what you obtain by a bachelor in physics, or sometimes also in other disciplines, like chemistry or certain engineering courses. And we evaluate also your English fluency, because there is actually no certificate, English certificate is required in our degree, but so the only necessary step is to undertake this interview in English. Okay, so with this, I thank you very much for your attention, and I flash here the informations where you can, a few lines where you can find more information. So mostly our website here, and you can always write to the International Welcome Desk of our university, or the director of the program, Professor Paolo Bordone, or if you like, directly to me, Guido Goldoni, by email to have more information. Thank you very much.
Professor Goldoni, thank you so much for your presentation. Professor Iori, the floor is yours.
Thank you. Thank you very much, Lavinia. So can you tell me if you see my screen?
Yes, I confirm.
Okay, thanks everybody for being here. I'd like to quickly introduce to you the master's degree in digital automation engineering. This is a new degree that we just started this year at the Faculty of Engineering of Reggio Emilia and the University of Modena and Reggio Emilia. So I'll go quickly to what I think is of interest for you. So digital automation engineering at a glance aims at training engineers in the new field of digital, let's say, revolution. We would like to provide the students with all the necessary expertise in the basic knowledge, like mathematics, computer science, and then also in the advanced technology typical of automation. So it's innovative, it's not only new, but innovative, and it's interdisciplinary. We will see how. We aim at two main types of automation. The first one is the physical one, robots, and the second one is the algorithmic automation, so bots. And of course, all lessons are taught in English. So it's considering the degree, the class of degree, it enters the class of LM25 degrees, which is automation engineering. So we have 16 such courses in Italy, so we are not the only one. We are the last one, and I believe we are very innovative because we are the only one with a focus on computer science. So the only one who has digital in the name and a strong part of it dedicated to machine learning and artificial intelligence, as you can see from the slide. We also have the basics of mathematics, like optimization, which is what I do, and statistics. And then we had other activities that you may know from previous studies, like simulations, CAD, CAM, electronics, and robotics, for example. So let's have a look at the way to access the course. So first of all, it's a free access, so there is no limited number. We started in September. At the moment, we have about 20 students following the class, a little bit more than that. So we are happy about the initial result. To enter the class, if you come from an Italian degree, you should have at least 80 over 110. If you have a bachelor degree, I mean, if you have a degree from abroad, then you need 2/3 of the maximum score, or you need to be in the top 30% of your reference group. And then you need to have also some background, so you can come from either engineering or science, but you need to have some backgrounds. For example, 33 credits in core topics like mathematics, physics, and chemistry, and 6 credits in computer science, and then 12 credits in automation engineering subjects, including automation control, electric drives, and applied mechanics. Then you need adequate English knowledge, so that's a B2 level, and you should contact us at info.dae@unimore.it to complete insufficient HCTS if you need them, or to get some more information about the English language level. So we have several exams that are given online for free, where you can get this B2 level for the University of Modena, Reggio Emilia. The lectures are in presence. We are in the city center of Reggio Emilia in a historical building, and attending classes is not mandatory, but of course strongly recommended. In case you cannot attend for a few weeks because you are not there, full videos of all classes are uploaded after the class has been given on the web, on a dedicated website. Let's have a look at the structure of the course. So the first year is the same for all students. So we have core and compulsory topics. Then at the second year, you can choose your path among 3 different, let's call them curricula. The first one is in infrastructure, the second one in design, and the third one in manufacturing. We will see the details of them. Then in the second semester of the second year, the very last semester, you have elective courses, internship, and thesis. So in the first year, you will see the basic of probability, statistical methods, and then optimization methods, artificial intelligence and data science, and then that's the first semester. So you see mathematics and IT. And then you will do the basic of automation with collaborative robotics, electric drives, and simulation experimental model analysis, which is the mechanical part. In the second year, you have the last common course in which you will study automated plants. And this is industrial plants. Then, if you want to choose infrastructure as a curriculum, you will focus on secure data transmissions, distributed system, and IoT applications. So you will disregard the mechanical part of automation and focus on IT. And you will see distributed control, distributed and Internet of Things software, smart system for data acquisition, that's another one, and high performance computing. So this is ideally if you are more interested in computer science, in the algorithmic and software part of automation. If instead you want to move to digital design, then you will focus more on the mechanical component, mechanical and electronical component. So you will have to, you will be able to study the design and development of automation system and the modeling of complex system, also thermofluid dynamic processes. So here you have multi-physics flow modeling, one course, computational thermofluid dynamics, again, digital multi-physics simulation, and product design and digital development. So this is the design of a product from an automation engineering point of view. The third curriculum you can choose is digital manufacturing, and this is more concerned on the management of manufacturing plants, of digital automated manufacturing plants. So you will have virtual solutions for smart manufacturing, material design and optimization in digital manufacturing, organizing for digital transformation. So this is again activities related to the management of a plant. And then again, sustainability, which we cannot forget, and digital transformation. So this is the second year, first semester. And there you have your 4 courses. After this is done, then you will enter the last semester of the second year. And there you can complete your classes with elective courses, selecting courses from other curricula, from other degrees, either in Reggio Emilia or in Modena, including those of my previous colleagues in electronics and physics. You can otherwise do laboratory activities. There are interesting laboratory activities. One, for example, is based at the CERN of Geneva, and that's called a challenge-based innovation, where a few students are selected and they are sent to Geneva for a couple of weeks, one at the beginning of the semester and the other one at the end. Another one is called RED project, and we are developing a rover which is supposed to drive on Mars, for example. And there is a competition, and so far we are #1 in Europe, and you could be part of this rover activity, the development of the rover. And you can also do internship in companies and organizations. Actually, the internship is compulsory. unless you do a laboratory, so either laboratory or internship. And it lasts 600 hours, so it lasts an entire semester, and in this way, you'll be able to learn how to work in a company. There are a lot of companies that are willing to open their doors for internships. We have many already. In case you want to leave Reggio Emilia and move abroad, then we have again Erasmus Plus and more overseas. So digital automation has the advantage of having all the exchange programs already signed for industrial engineering. So we have programs going on with Norway, Denmark, Germany, Netherlands, France, Spain, Turkey, and so on and so forth. We also have Japan and Brazil, by the way, as more overseas. We also have Chile, Concepcion. And that's if you want to do a semester abroad. After this is finished, well, you can continue studying, and you have access typically to secondary degree masters or especially PhD schools. We have our PhD school here at the Department of Engineering. Otherwise, you have several employment opportunities. And I'd like to stress the fact that the companies are entering the degree. So you will meet a lot of companies during your degree. In fact, each course we will give will host a seminar by a company. So this year we just started, but we had Electric 80, which is the main producer of laser-guided vehicles in Italy. And we have Credem, which is a bank. And Credem is producing bot. It's doing a lot of things by bot. And Credem is also financing full academic fees for 2 students. So we are collecting grants. And Credem is giving the 2 first grants, and they are 5,000 euros each grant, and that will cover the fee of one of the students. So I'm going to finish now. I'd like to say that you can apply for the course, having a look at this difficult website here, or you can follow our dedicated website, which is www.dae.unimore.it. And here you can find all information, how to reach us, how to contact us, and how to apply. And I'm Manuel Iori, but I'm also in the group with Stefania Monica and Fabio Movilli, who helped me coordinating this master degree. And we read emails at info.dae@unimore.it. So feel free to write us. Thank you again. I don't want to continue because I think now it's time for questions. So Lavinia, please feel free to take the stage.
Yes, absolutely. We do have a couple of questions, and I would like the participants to write some more if they have any. So I will start by asking if you have the knowledge of what are at the moment the most in-demand master's programs. So what is the industry demanding in your experience?
Who's gonna answer this?
Whichever professor prefers to
Well,
start.
I mean, what we, I will start with saying that in general, industry is desperately asking for STEM type of education, and engineering and physics stand at the highest places in this hierarchy. Within the engineering field, certainly that of electronics engineering and in general, what we call here information engineering. So all the area that has to do with the new challenges, with the new technologies are bringing us is definitely, as I mentioned, the electronic engineers, for instance, stand in all the evaluations as those that are most paid above average, and within the field of engineering also the most paid. They are desperately demanded right now. We have to add a specific fact that Europe is heavily investing to reshore within Europe microelectronics, nanoelectronics, basic electronic technologies that are enabling technologies for all the ICT world at large. and they are also enabling the revolutions of artificial intelligence, big data science, and so on and so forth. So these, as far as we can say, are definitely the areas where there is the largest demand at the moment.
Thank you so much, Professor Selmi. Professor Sgoldoni, Yori, do you wish to add anything else?
From this point of view, physics is a bit specific. I mean, some of the physics degree get an employment typically in any high technology company. Some of them because of their expertise in some field, say material science, I would say. But in many cases, it's not what they exactly know to do, how to do, but it's more that they can be figures which are able to interact with other professionals, engineers, chemists, and other scientific figures. So physicists are often, of course, managing research and development labs in the companies where they work, but not only in R&D labs, but also, for example, quality control or other aspects by connecting strongly with other professional figures. And also there are other type of companies which are not technological in this sense, but where the expertise and abilities, so to say, to manage mathematical models is also very important, say, for example, insurances and banks.
Thank you so much, Professor Goldoni. Professor Yori?
Yes, so digital automation has a lot of different opportunities in terms of employment. You can find, let's take, for example, classical production activities, like if you want to produce a laser-guided vehicle, there are a lot of things we have to do. Like first, we have to think of the robot that is there. And then second, we have to think of the algorithms inside the robot. So there are several things we have to do in order to be able to produce one. So we find more and more digital automation, for example, in intralogistics. So moving products inside a warehouse, inside an industrial plant. We can find it also in logistics, like all these cars that should be able to move on their own, and so far they're not able to do that yet. And apart from that, so production, logistics is the natural field of digital automation engineers. Other fields are related to the pure development of algorithms. So banks are hiring digital engineers because they need them for a simple process. They have to be able to collect data, then analyze the data, process them, and then use the data to optimize something or to manage something. And this something can be something physical or virtual. And so we will find plenty of applications for the digital automation engineers. Thanks.
Thank you, Professor Yori. So to go back to Professor Goldoni, we have a participant who got their Bachelor of Science in Physics. Of course, they completed all their degree in English, so they want to know whether they need an English certificate proficiency or not for being admitted to the Masters.
No, there is no need for an English proficiency certificate. We just have an interview, which is, of course, taken in English, and that's the way we make sure that your English is a good level for our program. But as for the other degrees, B2 level is the normal level, but no certificate is required.
Thank you so much, Professor. So I see a question about the CERN challenge. A participant is asking how difficult is it to actually get picked?
Well, obviously, it is the most difficult challenge. So we select 4 students per year at most. We have 20 now. I think we're going to have a few more. So it's not so difficult. But of course, it's a challenge. If CERN is not selected, there are other options. Like, of course, one should try. But the other options has either here in loco, for example, the development of the rover, or in other laboratories, For example, we have 2 students each year selected for Japan, and they have a very nice laboratory in Nagoya University, where Toyota is also working, just to give an example.
Lavinia, if I may add, we also participate with our master degree in physics in the CBI challenge, and in a few years of experience, 1 or 2 of our students take part in this CBI or in another project which is called Sugar, and they either go to CERN or to Stanford University or other places that I think they stay there for they go there 3 times for 1 week, something like that.
Thank you, Professor Goldoni, Professor Iori as well for your replies, and Professor Goldoni, also thank you for mentioning these amazing opportunities. So to move forward with the questions, a participant is asking actually about the application process. So if there's any flexibility that you know of, as they might require some time and actually be stressful. Do we have any notions on how the admission process works, or should we direct them to the International Welcome Desk email address for any related questions?
Yeah, well, I can maybe answer this a bit. First of all, I'd like to say that I did not touch these points explicitly in the presentation, but the presentation that will be left and sent by the Docsity organizers will actually contain at the end a few slides with all the references to the application forms and the application procedures and so on. This is usually streamlined, and for any issue that might arise along the process, you will have contacts in the professors that I mentioned at the end of my presentation, which are responsible for the course of study, so that will help you on a, I would say, personal basis almost to solve and overcome possible issues that might arise. So, of course, something can happen that don't go perfectly straight, but we never heard about students being excluded because of this. So I would be rather confident that the process would go positively to the end.
I'd like to quickly.
Yes, sure, Professor.
I'd like to quickly mention that I believe that for all of us, applications will end on 14th of December, if I'm not mistaken. So there is still some time to apply, if I'm not mistaken, for all of us. Yeah.
Thank you so much, professors. Of course, participants will absolutely get an email with the recording of the event, and also with all the slides and information to apply should they want to do so. So I see a question about any discipline, I assume any subject or any masters that actually deals with the care of advanced traffic control system.
Well, the master in electronics engineering actually has some courses which are slightly related to these topics. I mean, there is not a specific course on this, but courses on automotive connectivity and other aspects of mobility are very much in the at the heart of the specialization that you can get in UNIMORE in general. I would say that this is transversal also to the other master degrees that have been presented today, because this is really the heart of the motor valley. And there is a tremendous effort and a tremendous presence of companies and expertise and knowledge on these topics, both in academia and in an industrial environment.
I agree with Professor Selmi. Thanks. He said very well. It's transversal, I believe, to all our degrees. Thanks.
Thank both professors for their answers. So I still see some questions, of course, about the available scholarships for those types of questions, I would direct it to the international welcome desk at unimore.it. Of course, you will have also the information in case you wish to apply. So if none of you have any more specific questions for the professors, I would like to wrap this presentation here. And of course, I would like to thank Professor Selmi, Professor Goldoni, and Yori for their presence and for the time they have taken to give these presentations and to answer all the questions. Once again, I want to remind all participants that they will get an email with the recording of the event and as well all the PowerPoint presentations and the information, of course, to get in touch with UNIMORE. So once again, thank you, professors, for your presence.
Thank you. Thank you very much.
Thank you very much. And I hope, thank you so much. And I hope to see all the participants once again for the next event, hopefully with UNIMORE. So without further ado, I wish everyone a nice evening or a nice day according to where they're connecting from, and stay safe. Until next time, bye-bye.
Bye.
Bye.
Bye, everyone.
Bye, everyone. Bye-bye.